Hi, my name is Ethan. Welcome to the 2020 Penn State IEEE Winter Break Workshop. I hope everyone is having a nice, relaxing break so far, and I really want to thank you all for participating. I know everyone is really excited to jump into the project, but first, IEEE would like to thank Kimberly Clark for their generous support of this year's Winter Break Workshop. Kimberly Clark is an industry leader in the manufacturing of paper-based consumer products, and the work they do requires bright minds of engineers just like yourself. Kimberly Clark is currently seeking electrical engineering students interested in a fall co-op. So if you're interested in this opportunity, please reach out to Avery McGinnis at acm73@psu.edu, and he'll be able to put you in contact with a Kimberly Clark recruiter. Once again, thank you, Kimberly Clark. Now back to the project. During the development of the idea, circuit, and layout for the project, there were three things that I wanted to keep in mind. Flexibility, simplicity, and ease of use. The project needed to be flexible enough so that it can be customized, reprogrammed, and reused in case of technical difficulties. And it needed to be simple enough that all skill levels could understand the project, and it needed to be easily produced and soldered by everyone. And some of the components that you'll see on here are a little bit tricky to solder, but you'll be able to get the hang of them after this little tutorial here. I settled on a microcontroller-centric design, so I chose the ATtiny 412. It's a nice little chip. It's only an 8-pin chip, but that's all we need. It has a power in, a ground, a reset, which is the only pin that's used to program this thing, and you have 5 GPIO pins to use. And we'll go ahead and take a look at the schematic here in just a sec. So here we are taking a quick look at the circuit and schematic here. You'll see that there are really 4 main components to this, and I'll go over them all in turn. First and foremost, up here we have the microcontroller itself. You'll notice that this is the only part that is already soldered onto your boards. Hopefully, if this focuses there you can see it. It's that tiny little guy between the Penn State logo and the Happy Holidays. So that would be a little bit too hard to solder on your own unless you either have a reflow oven or a very precision air soldering gun. But everything else on this chip, or everything else on this PCB, I should say, is going to be easily hand solderable. So that is the first thing. Don't have to worry about soldering that, but it is the brains of the operation, so make sure you pay attention to that. You're going to see a couple of lines on the side here, 2 of which are actually going to be broken out on the PCB. See if you can find this little guy right at the bottom there. Oh, there it focuses. Right above my finger, you'll see it says VDD, RST, reset, and then ground, GND. The VDD is just going to be your voltage in, or your high voltage here, but also on the side, you're going to be able to see a clock and latch. So these are going to be connected down here to our shift register, and this is what's going to be directly driving all of the LEDs that you get in your nice little baggie right there. So when we're taking a look at the shift register, there are 3 really important lines that we got to take a look at. Data, which you'll see is on the left side of this chip here. Clock, which we already saw on the right side of the chip, and latch, another one on the right side of the chip. So there is a library that's used, and if you're interested in finding out more about this for yourself, I really encourage you to do a deep dive. There's actually a website called All About Circuits, which hopefully you'll see a video coming on that soon, that goes over in depth how a shift register works and how it's going to communicate with the Arduino. But just for today, understand that the Arduino is talking to this other little chip, which you'll see is this bigger outline. If you come look at my screen down in the corner right above my finger there, the big outline. But the Arduino microcontroller, I should say, is going to be talking to that chip to go ahead and output different levels to these LEDs, which you'll see is the third major component. We got the first one here is our microcontroller. The second one is our shift register, and the third is the LEDs grouped in with the resistors. You'll also notice on your board, go ahead and take it out there for a sec, that you don't really see many holes for resistors there. There's a reason for that. The resistors that we're going to be working with today are surface mount, which means they don't go through holes. They're a little bit trickier to solder, but that's the fun of this project. The fourth component is actually twofold. It's just the breakout holes. So you notice the ones that I pointed out earlier, you'll see them on either side of the board, but it's just gonna say ground, reset, and VDD. And then you also have two more. If you can spot them using this little connector here, they are actually part of another breakout here. You have two more pins that we're not even using. So I figure why not let you guys play around with this after the fact. You'll find them at the very top of the board, almost near where you hang it. There should be two little holes labeled 0 and 1. Those are gonna be Arduino pins 0 and 1. And if you get creative, you might be able to hook a speaker up to this, or hook, heck, even another shift register up to this, and go ahead and experiment by adding your own components to this. All it needs is power, and you can program it with a regular Arduino, which we will see here in just a minute. So, just wanted to give you an idea of what the schematic looked like. It is pretty simple, all in all. You really only have, I don't know, 20 components on this thing that are really that important. So, I'll let you guys take a look at that. You can always pause the video if you need to. We're gonna go over just to show you kind of what the board looks like whenever I'm designing it. It looks a little funky. Hopefully you can see this here. Let me go ahead and switch my window over. And yeah, there we go. So this is what it looks like whenever I'm designing these boards. I know I've already done a design workshop, but just so you could see it, I think it's neat being able to look at it. So you could see the little microcontroller chip right there. You got the Happy Holidays Penn State logo, all of these resistors up on the sides, and of course the LEDs all around the outside. So let's get into the meat and potatoes, the real fun stuff of this workshop, and let's get to soldering. I'm going to show you how to first solder on the resistors, second solder on the shift register chip, and third and finally all of the LEDs. After that, we're going to program it, and you guys can go and enjoy your new ornament. I'll say holiday ornament. It's not for Christmas. It's not for any one specific holiday. It's for you and your families to enjoy, and even your friends too. So let's get into some of the soldering. You can see here I've got a couple of tools as well as the PCB I'm going to be using set in front of me. So from left to right, you're going to want some solder. That's going to be for your soldering iron. You're probably going to want a pair of nice tweezers. If not tweezers, I've found that also a regular just wooden pencil might work for this. You'll want something that's a little bit heat resistant, also that's not going to burn your hands. These iFixit tweezers are really nice because they are not going to burn your hands even if the front gets a little bit warm, and they're also ESD safe. So next up, obviously, we have our PCB here. Our soldering iron, which you right now can go ahead and, remember, remove this from your table before you do so, but I want to put this back in its holster, and I'm going to set this to, mine is about a 7 on here, so I'm going to go ahead and click it on. I'll go ahead and put that in the holster and let that warm up for a little bit. Also, some trimmers. Scissors will do in a pinch if you don't have something like these, but you can get something that is going to be cutting off the leads to the LEDs that you have here. So the LED leads are really, really long for these, just a little bit easier to work with. And you're not going to want those sticking out of the back of your PCB. You can see this is KT. I'm actually making this for my sister. But yeah, you can tell that the LED leads are going to be a little bit too long for this. So let me clear away these tools here for a sec, get them out of the way. We'll go ahead and take a look at what's in the kits that you got. So you should see this nice little pack here. It's going to have everything you need in it to build these kits. The programming part's going to come a little bit later, but let's go ahead and just dump this out and sort this out a little bit. So you notice that, the LEDs don't get stuck here. You'll notice that you have 3 individual little things here, as well as the baggie, but the baggie's not going to be too important. You're going to have 8 LEDs, which you're going to be using to obviously put on the kits. You're going to have some resistors to go with the LEDs. Now, you'll get 10 resistors in your kits. Sorry if you got less than 10. If you got more than 10, I don't know, you can pawn them off. You're only going to need 8 of them, but we gave you 10 just in case maybe you drop one, you screw one up and have to rip it off. Maybe they break. These are kind of fragile. And then also you have your shift register. So this is going to be the good stuff right here. Additionally, you'll find a little cardboard box in your kit. I'll go ahead and clear these off to the side. Just leave them right there. You'll find a cardboard box in your kit. It's going to contain a battery, and this is not in every kit that you get. This is only one. You should find it in the box for your shipment, but you're going to get a battery. You're going to get a charge module. You should have a capacitor. The leads are probably going to be straight. This is one that's already been used. And you should also get 3 wires. They may be different colors, but you will, by default, get 3 wires. If you asked for some solder, I made sure to throw some solder in there. If you asked for extra wires, I made sure to put those in there too. But 3 wires is really all you're going to need to get started with your setup. So, this is everything that should have come in your kit. If you did not get, well, one of these, or maybe more of these as well, if you did not get any of these, or if you got too many of them, please let me know. You can go ahead and message me on Discord, or you can go ahead and shoot me an email. Everybody who participated in this should have my email. I sent out a few in that chain. So let's go ahead and get actually started building this. The first thing that we're going to do is tackle these resistors. Let me clear everything out of the way. Hopefully it's off screen. Also, something else, you might want a USB-C charger for this. So go ahead, you can plug this in. It's really only going to fit in one way. So while we're working, I would really recommend going and plugging this in to get it to charge. When it charges, you'll see a little light come on, and when it's done, there'll be another little LED on here. Let's see if maybe we can zoom in. Oh yeah, nice and tight. So taking a look at the board, there is a little jumper here. You'll notice that mine has some solder on it. Yours will not. It will be 2 separate ones. By default, it charges at 0.1 amps. This just makes it charge at half an amp. So you can make it charge a little bit quicker. I just decided to do that because I was lazy. But you'll see there's the charging indicator and a done indicator. So go ahead, plug this in while you're waiting, and save yourself some time from charging it later on. All right, I'll go put this off to the side. Also, if you're worried about damaging, let's go ahead and zoom back out. If you're worried about damaging, a countertop or a nice table that you have, I'm sure everybody has extra cardboard laying around from some Amazon packages. You can see I missed the little black thing there. But you can go ahead and put this down so that you're protecting your table a little bit. Or, if you're working on a countertop, a nice granite countertop that you don't want to get scratched up or anything, make sure to put something down. Now this table, I made it myself. I don't really care much about it. It's a work table. But I'm going to go ahead and put mine off to the side. And we're going to go ahead and get started on this. Seems like my soldering iron is hot. Yeah, there we go. It's nice and hot. But first of all, we want to get out all of these little guys. And they are pretty small. But you know what? That's the fun of this. You got to have a little bit of a challenge when you're doing a project like this. So I'm going to pull out 4, some dog hair, 4 at a time, and we're going to do each side at a time, okay? So I'll go ahead and pull these out. Again, a nice set of tweezers will do you real good with this project and for future projects. So I'm going to go ahead in here and try to open this up. Let me speed this along for you. There's a little plastic wrap on the top. Let me go ahead and speed this along. Okay, I got it off and they're already starting to come out. I'm just gonna try to scoop 4 of these out and maybe leave the rest of them in there. Oh, well, I got more than 4. I got 5. That's fine. I'll get this 6th one out. It seems like it wants to come. Oh, no, now it doesn't want to come. Anyway, you can see I got them all here. Because they are resistors, they do not need to be oriented any particular way. Although I'm going to try to get them oriented nice so they read 330, or actually it's 3300. You can tell the values on these. It's going to say, 330, and the last one is going to be a tens multiplier. Oh my gosh, can't even see. I don't even know how close I'm going to be able to get with one of these. And my camera is not going to focus. But they are very... It's a good thing I caught that. They are very, very small. But you should be able to read them just fine. We're going to be working with them but I'll put them off to the side right now. Actually, the first thing that we're going to do is make sure that we got a nice and hot soldering iron. And we're going to go ahead and we're going to warm up one of these pads. I'm right-handed, so I'm going to warm up the right side of it first. You also might want to tape your PCB down if it's wiggling around. Some of them do kind of swivel and rotate a little bit as you're working. But I'm going to go ahead, I'm going to heat up one of these pads. And I've got a pretty chunky one, so if I can do it with this, you should be able to do it just fine with anything else. And you'll see there's just ever so slightly a tiny bit of solder on there. I mean, I just barely touched it. It is not sticking up, it's not tenting, there's not a big glob on there, it's just barely covering the pad. I'm going to do that for all 4 of these pads on the right-hand side. So let's go ahead. I'm going to go ahead and heat up the pad. Heating up the pad is pretty important because it just means that you can barely touch the solder to it and it'll already melt to that pad. Now you don't want to keep it there for like a minute or so. Barely touch, barely touch. So there we go. I just have a tiny bit of solder on each of those right pads. I'm going to go ahead and put this down. Make sure you put it in the holder. Make sure never to touch the metal part when it's on. Speaking from experience, I have a couple of battle scars on my hands from doing stupid stuff like that. So we're just going to very gently go ahead and we're going to place this down. I'm sorry my camera can't focus in too much closer here. But you will want to get it in pretty tight. Oh, let me see if maybe I can zoom in on my other camera here. There we go. There's a nice tight zoom. Anyway, you're going to want to try to line it up just so it's covering both of those pads. It's okay if it's slanted a little bit. There are bits of metal on each side of the resistor. That's all that needs to touch. You don't need to cover them. They just really need to get on there ever so slightly. So what I'm going to do is I'm going to kind of hold it down with my tweezers in the one hand. And with the other hand, my dominant hand, I'm going to come in and just touch that solder until it becomes liquid and kind of grabs onto the edge of the resistor there. Again, it doesn't need to be perfect, it just needs to make an electrical connection. And I can tell because I can run my finger across this and the resistor isn't sliding around. That's a good sign. So now we're going to do that with the others here, and I know I'm switching hands a lot now, this is my left hand. But we're going to do this with the others. And so I'm just going to, like I said, place it down. I'm going to hold it down. Like I said, you could get a pencil for this, or even a tough wire maybe. Just hold it down and go ahead and heat up that right pad just until it becomes liquid and it'll grab on to the edge of the resistor. This solder that I'm using, you'll see it says rosin core solder. It just means the inside of this has a little bit of flux in it that helps the solder grab onto components. Helps it flow a little bit easier. All right, let me get these other 2 done, and then we'll go ahead and take a look at the other sides of them. There we go. And if your soldering iron is hot enough, it should only take a second. And I quite literally mean just a second. Yeah, that's what we don't want to have happen. I had one of these guys flip over. Also, they're blowing around whenever I'm just talking. Like I'm talking and kind of blowing on them. I did not think that they would blow around that easily, but you gotta kind of be careful with these guys. All right, there. That's that last one in place. So I'm gonna go ahead and just rotate this around. Literally 180, so it should be upside down for you guys. It's upside down for me too. Now the other side of them, pretty much the same thing, except there's already another pad there that you kind of have to worry about. So they're not going to move because that other pad is already cooled. But what you're going to do is you're just going to touch to the other pad. Go ahead and give it a nudge. Make sure that the solder flows in there. Let's go ahead and see if I can maybe get it better. Yeah, there we go. So that first one you can see just with the shine on it, you can see that the solder flowed a little bit more than I had liked, but up onto the metal part of the surface mount resistor. And that looks perfect. And again, we're just going to do that for all 4. And this process should not take very long at all.
Oops.
And there we go. So that is the whole now right side finish. You're going to go ahead and duplicate that on the left side using the same exact techniques that I did here. Go ahead and put a little bit of solder onto each one of those pads, and then go ahead and place the component down either with some tweezers or nudging it into place with another object that you're not going to worry about burning or getting too hot near your hands. And then once those are all in place, you're going to do the other side just like I did these. So you can go ahead and rewind. I'll give you a couple seconds to do that. And I'll be right back as soon as I have my other side done. Okay guys, check it out. Got all 8 of these soldered on. Feel pretty good about them. I only lost one. You'll see here I just have a lone one. So you know what? Nobody's perfect. Not even the guy who designed this workshop. So maybe I'll find it in a couple of days once I'm cleaning off my desk. But anyway, there we go. So we have all of the resistors soldered on. If you're worried about there being some gunk on here, I'm not going to worry about it right now. I'm going to go ahead and finish my project first. But you can get a little bit of rubbing alcohol or isopropyl alcohol, and you can go ahead and just put some on the tip of a Q-tip, or if you want maybe like a paper towel, and go ahead in between there, and it should clean up just fine, and it's not going to ruin any of the nice silk screen or any of the solder mask. It's just going to clear off some of that extra flux. It may look burned. It's not burned. It's just the flux, whenever it helps things move around, it does dry up a bit, and it leaves kind of that nasty little residue. But the next part that we are going to be working on is this guy right here. So this is the shift register that I had talked about. Now, the one thing you'll notice about the shift register is there are 2 little indicators here, which side is which. The notch is going to be the real one. This one down here is probably just quality control or something like that. But the notch is going to be really important because when you turn it this way, the notch is going to indicate which pin is actually the first pin. And it'll be the top left one here, and you go around counterclockwise. So the top left pin is going to be pin number 1. Top right is going to be pin number, however many pins are on this. I think there are 14. 14 sounds about right. So we're going to do this one next. One of the main things you got to worry about when putting this in, you will realize that it doesn't go in nicely right away to these holes. Now, of course, I have it on the desk, so it's not going to go all the way through. But the feet are spaced a little bit in a V shape. Let's see, can you see that? Yeah, there you go. It's a little bit in a V shape. You can very gently go ahead and just press it down onto the board. Gently, gently, gently. And kind of get them into a little bit less of a V shape. Let's go ahead and do it to both sides. You may need to do this a couple of times before it fits. There we go. That's looking a little bit better. Let's try one more time on this side. Now, realistically, if you're going to be designing a project or a product, you're not going to need a little carrier, something that you might solder in before you solder in this chip, just in case you need to replace it. But because this is kind of a one-off project, we're not going to use one of those. You're not going to be taking this back out and reusing it, most likely. Go ahead and put these in here. There, it should be nice and snug in there. Almost don't need to solder it in, but we will solder it in. But we're not going to put a little carrier or a holder on. We're just going to do it kind of bare board. It keeps the board profile a little bit slimmer too. You can see it is nice and slim. If it weren't for this big chunky thing and all the LEDs we're putting on it, it'd be really nice and thin. Anyway, go ahead and flip this over. Once you have it in, it should be in there pretty tight. It shouldn't want to wiggle out for you. You're going to go ahead and put it over like that. I'm going to put it on its back. And we're going to go ahead and solder all of these little points. What I like to do is first solder the top right and then the bottom left, That way I know that it is not gonna come out no matter what I do. So, go ahead, make sure your soldering iron is nice and hot. My tip is actually a little bit dirty there on mine, so let me go ahead and just kind of clean it off. I've got one of these nice ones. Oh, sorry, the camera's shaking. Got one of these nice ones where it has a little bit of almost a steel wool and a little sponge that you can wet. I find that those work very, very well, and I like just having that readily available. Anyway, so go ahead, you can just push it down a little bit to make sure all the pins are in. Make sure none of them are bent. You might want to give it a closer inspection, but I'm going to go ahead and do this top right one. Go ahead and hold your thing on there for, I don't know, 2 or 3 seconds. Go ahead and lightly touch it with that. You really don't need a lot, to be honest. And we can go ahead and inspect this one. Go ahead and put that down for a second. Let's go ahead and zoom in here a little bit. So we can go in and inspect this. I know that the camera's not doing a great job at focusing, but it should look kind of like the end of a Hershey Kiss. You don't want a super big blob. You also don't want to see like an indent to where the hole is. And you might see maybe a little bit coming up on the other side too. It's just grabbing a hold of the pin, just shaking its hand. But yeah, you don't want too much. You don't want too little. You want just the right amount. Anyway, let's go down and do this other pin down here just to make sure it really doesn't come out. Go ahead, heat it for a couple of seconds. Go ahead, give it a little bit of solder. Wow, that one's looking nice. So then you're just gonna do the same thing for all of the rest of these. You're just gonna go through, I'm gonna do the left side first and then the right side. And when you're done with that, we'll meet back up. I'll go ahead and speed this up for you, but you take as much time as you need. Everybody's gonna be at different levels when they're soldering this, so don't feel bad if it takes you a long time. It takes everybody a long time to start out. So let's go ahead and do the rest. All right, there we go. Not too bad looking. You will notice that I got some flux on the sides for whenever I'm soldering. I think my soldering iron was turned a little hot. Down there I did manage to scratch the solder mask, which provides a nice mask and protection from the solder to all of these little traces and stuff. You can kind of see in the reflection there. But all of these little traces actually need to be protected from the solder because it could bridge some gaps like there. You can see a couple of traces are pretty close to one another. You don't want to bridge those gaps, trust me. It's gonna break your project pretty quick. So, like I said, a little bit of rubbing alcohol. We'll go ahead and wipe those off pretty quick, but I'm not gonna do that till the end. Now comes probably the most fun part. Go ahead and pull out all those nice LEDs that you got in your kits. I'm gonna go ahead and zoom out a little bit. There we go. See my solder up there. So with this one, like I said, I'm making this for my sister, and she wanted some blue and some red. She would have preferred purple, I would imagine, but these are the two closest colors we've got. Here we go. So you will notice that on each of these, gosh, now I gotta zoom in again. I'll just hold this up. On each of these sets for the LEDs, you're gonna see one that has a plus next to it and one that has a minus next to it. In addition, you'll see this straight black line there, just for reference. On an LED, now I wish I could show this, I'll probably throw up a graphic, but on an LED, you'll see that one of these sides, there we go, one of these sides is gonna be flat. You'll also notice that that flat side corresponds with the shorter leg. Yes, these LEDs are made so that the legs are not the same length. The shorter leg is going to be your ground or your minus, and your longer leg is going to be your positive or your plus, whatever you want to call it. So I think I'm just gonna go ahead and put these in and alternate them. I think that's what she wants. So again, if you're looking at it like I am, the longer leg is gonna go in the left hole. Longer left. Whatever you need to think about when you're doing that, go ahead and do so. So I'm gonna go ahead and just arrange these. You can arrange yours however you would like. You can put all of one color at the top, the other color at the bottom, do left and right. If you only got one color, then well, you're kind of limited on customization options here. But I'm just gonna alternate mine. I think it looks good, and hopefully she'll like it as well. Let's go ahead and put these in. Also worth mentioning, don't put it on the desk. You put it on the desk, they're gonna pop out. You can see they're kind of shaking and popping out there. Now this next part, this is gonna take all the skill in the world. Go ahead and put your hand on it. You might need to use the edge of your desk or however you want to do this. Maybe you can do it quickly, but you're gonna want to flip it upside down and hope that everything stays in the right place. You'll see that they kind of wiggle around, but this is actually gonna hold the LEDs in place while we're working on it. If you have a piece of cardboard, it's probably best. It'll keep them all up at the same level so they're flush against the board on their back sides. But here is another fun part. You're gonna go around with your soldering iron. I'm gonna clean the tip of mine here in just a sec. You're gonna go around with your soldering iron, and I would recommend doing all of the one side first, just to make sure that they all stay in. And then you can go back and, of course, do the other side. It doesn't matter after that point. But, yep, that's what I'm going to do right now. So go ahead, you're going to solder them just like you soldered these through holes. You only need a little bit of solder, but make sure you have enough that you have that nice, almost Hershey Kiss-like shape to them. So let me go ahead and clear off my tip. Sometimes it also helps if you pour a little tiny bit of solder on the top of it, which is called tinning. Helps the solder flow a little bit more evenly. But I'm just going to do all of the right sides first because I'm right-handed. And then I can come back and do the lefts. The nice thing about these rolls of solder is you can kind of just hold them in your hand and thread them through as you're working. It is very nice. You could turn the solder, you can bend it however you need it, just as you're going around. Oh, that one was kind of bad. Let's hit that again. Now this is a point where it would help for you to be able to move it around. Apply a little bit of pressure in areas to make sure that it is right as rain. Here we go. Okay, so that's all of the right sides soldered on. I'm just gonna go ahead and flip this and take a look. I can see like this LED here, it's kind of at an angle. So what I'm gonna do is not touching right near the bottom of there. I'm just gonna go ahead and put a little bit of pressure and reheat where I soldered. And there we go. I should be able to even it out. Just all you need to do is touch it. Let me go ahead and take a look and see if there are any other LEDs that happened to. Yeah, these two down here, it looked like I kind of slacked on these guys. So I'm just gonna go ahead, lightly touch it while putting some pressure on it, and that should flatten it out. Let's do this one. But you see how much easier it is once all these are in to then go back through, and you only do one leg, so you don't have to try to touch the soldering iron to both legs to get them situated. You just need to do it into the one. But I'm pretty happy with the rest of those. So now I have to go back through and do all the other side because I'm right-handed. I did the right side, but if I rotate it 180 degrees, voila, the right-hand side is now the left-hand side. So I'm gonna go ahead and just go around and do all of these now. Hey, there we go. It's looking good. I have all mine soldered in now. So I'm gonna go ahead and put down my soldering iron for a while. You might not want to turn it off, but definitely put it off to the side because our next part is gonna use these clippers right here. Like I said, these are too long. You don't want this sticking up. You don't want somebody impaling their hand on it. These are kind of sharp, actually, once you feel them. But we don't like them sticking up that far from the desk. You can see there on the other camera. So I'm going to go ahead and trim all these off. I know from firsthand experience, when you're trimming LED leads, they have a tendency to shoot off in all sorts of directions. So sometimes if you put like a bag or something, I'm just going to lightly touch my fingers to them, not pushing because you don't want to impale yourself, but trimming off so you leave, I don't know, 1/4 centimeter, a few millimeters. So they're about even with the rest of these pins that you have in here from the shift register, basically. I'm just going to go ahead around and do that. This is really not hard. And if you're going to be using scissors, make sure you're not using mom and dad's favorite pair of scissors. Just go ahead and use maybe a set of craft scissors, something that's a little bit durable. If you don't have something like this, or some wire cutters may work as well. And there you have it. It's looking really nice, really clean. So now it's time to program this bad boy. This is where your Arduino is going to come in handy. You will need an Arduino for this. I recommend just a regular Arduino Uno because it's going to require the least amount of setup. And we're going to get into this here in just a moment. But I would urge you to take out your wires first. Okay? You're going to want your wires. You're going to want your capacitor for this. This is just some setup stuff here. I'll go ahead and zoom out. There we go. Wires and capacitor. I am going to go ahead and solder on my wires to these 3 pins here. Well, they're a lack thereof. They're going to become pins. I'm going to solder them through the back. My gray is going to go to ground. This brown is going to go to reset. And this orange is going to go to VDD. I know that you guys have different colors. Go ahead and do them whatever colors make sense to you. But we will be programming this. You will need to know what pins are which. I'm going to do that real fast. And once I've done that, I'm going to go ahead and transition over to the programming side of things. See you there. So you're probably wondering, how do we program this board with the computer? There's no real ports on this. You got 3 wires sticking out of it. You should have 3 wires sticking out of it if you soldered them on correctly. And there's really nothing else on here to indicate that it can be programmed. Well, 3 wires is all you need, and it's because of the interface that this tiny little chip uses to communicate with something like an Arduino. So I just have an Arduino Uno here. It's going to be the easiest. If you don't have an Arduino Uno, you can still do this project. You'll only need 3 pins on here. You'll see that you're going to need 5 volts and ground, which are right next to one another down here, and also reset, which is down here. And I lied, you'll need a 4th pin, whatever the pin 6 is on your device. You're going to need that. That's going to be the actual pin that you're going to use to program this. So, getting back to programming with the Arduino. If we're taking a look at this on here, this right now in its current state cannot program the chip that's on the PCB there. We're going to need to download a script first. Namely, it's going to be the one that's on this website. There's a really nice GitHub repository for a JTAG to UPDI. JTAG is the interface that this Arduino is going to support, and then UPDI is the interface that this PCB, your project, supports. So we're going to need a something to talk to them. You can go ahead here and click download zip, and it's going to download. I'll just go ahead and click this. I already have it up and running on my computer here, but it's going to download a zip folder, and you'll see you'll want to just copy this over to your desktop. But once you open it up, you're going to see all of these files in here. Don't be intimidated. This is perfectly normal. The only one you're going to want to open after you extract it is this JTAG to UPDI.ini. It's going to open up an Arduino script that you're going to upload to your microcontroller or whatever Arduino that you're going to be using. So let's go ahead and do that now. So once you've moved this folder over to your desktop, you've extracted everything. Normally it would say JTAG to UPDI master as the name of the folder. If you open this up, it's gonna say, you know, it needs to be moved into a folder. Just rename the folder that you dragged to your desktop to JTAG to UPDI, the same name as your .ini file here. I'll go ahead and open that up. It's gonna take a couple of seconds to initiate the Arduino IDE. But once you're in it, you're gonna see that the main folder, or the main file I should say, has nothing in it. Leave it that way. And you'll see why in just a moment. We're gonna go up here to Tools once you have your Arduino plugged in. So mine's gonna be the Arduino Uno. We're gonna find out what, what it's on here. So board, you can see I've already been experimenting with this, but I'm just gonna come over here, Arduino AVR boards, Arduino Uno, go back up to Tools. So it already identified that it's on COM3. This is the port that we're gonna be using. So I'm just gonna click that, and then I'm just gonna click Upload, and you'll see it's gonna run a script there for a little bit. Go ahead and give it some time. And uploading, done uploading. So this should be all primed and ready to go. We'll be plugging some stuff into it in just a second, but we have to figure out how we're going to program this, because this board, and especially this chip, is not supported by the Arduino IDE by default. We're actually going to come up here, we're gonna go to Tools, and we're gonna go to Boards here again. Oh, if it works for me, here we go. Board, there we go. And you'll see that I have a few more things here that you do not. That's okay, we're gonna get these in for you. We're actually gonna be looking at Mega Tiny Core. This is the one that we're gonna be using. You can see the ATtiny 412 down here. Well, it's right there. We're not gonna use the OptiBoot one. We're gonna use the ATtiny here. You don't have that yet. I'm gonna show you how to get it. So go into Boards Manager. Oh, actually, instead of Boards Manager, we're gonna close that for a second. We're gonna go to File, Preferences, here we go. And then you'll see this box down here that says Additional Boards Manager URLs. So here's what you're gonna do. I have a link down in the description. It's gonna look like a link. When you open up the link, it just opens up to a file. But you're going to copy that link and you're gonna paste it here. This is the link. You'll see it down in the description of the video. So go ahead, copy that in. I used this little button to open up this window here, and you're just gonna hit enter and paste it in on a new line. Should be this Drazy.com package, Drazy.com index.json. So once you have that in there, we're gonna hit OK. Gonna hit OK again. Then we're gonna go to Boards Manager. And you're gonna look up, so this Arduino AVR boards should be the first thing you see, but I'm just gonna type in Mega, hit enter. Oh, Mega Tiny. There we go. Once you type in Mega Tiny, you should see the first thing that comes up on here is Mega Tiny Core. So I have the most recent version installed. It's gonna say, you know, install here. You're gonna want version 2.1.5. There are tons of other versions here, but 2.1.5 is just the most recent, and it's gonna have all of the fixes and stuff ready for you. So once you've installed that, you can go ahead and close this window. Now we're also going to need a program to upload to this. I have a couple of sample programs. You'll see the third link in the description is going to be a Google Drive link to a folder that you can download that has a few different example codes, and we will see these in just a second. I can actually load one up here in my recents. So I like this round on, round off. See, it kind of opens over here. We'll go ahead and minimize that. We'll go ahead and maximize this. And now we're gonna transition back to our PCB and our Arduino to see a little bit of how we're going to put these together. Let's do that now. So taking a look at our Arduino Uno and our board, you'll see that there are some pins that we're gonna be using that I had mentioned earlier. Go ahead, first and foremost, and take your capacitor here. So this is an electrolytic capacitor, so the direction that you put this in does matter very much. You're gonna put the longer lead, and you can see that I've bent these to make it a little bit easier. You're gonna put the longer lead in the reset pin. So it should be down at the bottom of the board if you're looking at it this way. So if you have your ports on the left-hand side, it's gonna be down at the bottom. So you're gonna put one in the reset hole, which should be, yeah, the second one there, and the other one in ground. And I'm using just the far ground. And you'll notice that if there was a light on, you might have seen like a light blink. That's perfectly normal. You're not shorting out the board, you're not doing anything. It's just gonna prevent this from restarting. So it's going to constantly run this JTAG to UPDI program that we've uploaded to it already. So make sure you have that uploaded to this. Again, that's gonna be probably the second link in there, I believe. Or maybe the third, I forget. But you'll see it will say JTAG to UPDI when you open it up on GitHub. Anyway, with the longer lead in the reset pin, the shorter lead in one of the ground pins there on the bottom, you can actually kind of bend that backwards just ever so slightly so that we have access to these other ones. So you're going to take my ground and my VDD, so not this middle one, but my ground and my VDD, I'm gonna be plugging these into, the VDD is gonna go into 5 volts, the ground is obviously gonna go into ground, so let's go ahead and do that right now. Oh, and you'll see, this whole thing is gonna light up, except maybe 1 or 2 of them, because this has actually not been programmed. Oh, there we go, now all of them are lighting up. Anyway, then we're gonna go ahead and take this third lead back here, and you'll notice that it's maybe a little bit longer, a different color for you guys. You're gonna be plugging it into the digital pin 6 that's on the other side of the board. Hopefully you can see this here. I know I'm using my secondary camera, but digital pin 6. You're gonna make sure that it's plugged into that. So we're gonna go ahead and leave this here. With everything plugged in just the way I described. If you want to see a better representation of this, BitLooney actually did a really nice video. If you don't know BitLooney, he is an electronics guru on YouTube, and he's one of the ones that kind of inspired me to do this style of project. So let's transition back over to the IDE here. We're in the IDE, all right? We know that this is one of those new boards that we just installed. We're gonna go up to Tools. We're gonna go to Board, and then go down to Mega Tiny Core. You're gonna wanna select ATtiny 412, or the 402, 212, 202, right here. We're using the 412 chip. Shout out to my Pittsburgh area code buddies. Now, we're gonna go back up to Tools, and we're greeted with a lot more options now. The chip, you wanna make sure that this is selected ATtiny 412. It's gonna be the only chip that works with this configuration. Clock, you'll see by default, it might be on 20 megahertz internal. Now, if we're concerned about how much power this is drawing, especially when we have it hooked up to this battery that came with your shipment, and I'll show you how to do this in just a second. If we're concerned about it sucking up a lot of power, we can actually bump down the clock. I've noticed that 8 megahertz runs fine. You're not gonna see any performance hit. You're not gonna see anything but less power draw. The programs that we're gonna be running on here are not really all that power hungry, and they're not gonna require a fast clock. So I'm just gonna go ahead and click 8 megahertz internal. You see that kind of disappears there for a second. Let's go down through the rest of these. Millisecond or microsecond, we're gonna leave those enabled because we do need a timer running on here. Support serial event. No, we're not really gonna be communicating with serial for this program. You might wanna go ahead and communicate with serial for other programs. So, BOD, I think this is the brownout level. I'm going to go ahead and select 2.6 volts. The 1.8 volts, you'll see at 5 megahertz or less, we're running at 8 megahertz, so that's not gonna work for us. I'm just gonna select 2.6 volts. So, you know, if the battery drops to a certain level, it's not going to fry the chip because the chip's gonna try drawing power, but there's not gonna be enough power to sustain it. So just 2.6 is gonna be good for us. That just means at 2.6 volts, just turn off the chip so you're not damaging the battery, you're not damaging the chip on here. Again, we're gonna open up Tools here. Going through other things here. Yeah, nothing else is really gonna jump out. UPDI, this is the one we want. Port 3, you'll see it'll still say COM3 Arduino Uno, because the Arduino Uno is the one that's plugged into our communication USB port. You'll see the programmer down here. You're going to want to select JTAG to UPDI Mega Tiny Core. That's the program that we installed on the Arduino Uno. So after all of that's selected, you just kind of click out of here. Our latch pin is connected to the Arduino, or well, the internal Arduino on the AT Tiny chip. It's going to be pin 3. You want the clock pin to be 4, data pin to be 2. This byte number to display, don't really need to worry about that. You can just leave it at 0. Again, I'm using the round on, round off. And then LED speed is going to be the delay in between your LEDs switching. You'll see down here, it's just used in these delay functions. I set mine to 200. It's not too fast, not too slow. It looks nice, especially if you're going to hang this on a tree or if you're going to hang this somewhere around the house connected to some sort of power source. All right, so now we're going to go ahead and upload this. Ready? 3, 2, 1, go. So it's going to compile the program. You'll see some stuff down here. You'll see some warnings. Don't worry about that. Once it gets to this upload, so there we go. Done uploading. I actually had to, why you saw that jump cut there, is I had to unplug my Arduino first. I don't know why. Maybe it was just a little bit of glitchiness with the JTAG to UPDI. All I did was unplug the Arduino from USB and plug it right back in. I'm sure that does cause a little bit of reset, but you can see now that it is working beautifully. This is exactly how I wanted it to be. Now, you can tell the order of LEDs with this program. So the top one is going to be 1, and it's going to go around clockwise until you reach 8. So that's just how this is going to work. This is how I have it set. You can set it for the other direction. If you just want to literally invert some of these values on the program, there we go. It'll be these values here. So you can say it starts at 0 or whatever, or goes up to 8, or starts at 8 and then goes to 0, and it'll be I minus minus until it gets back there again. But you know what? Overall, I am really happy with this. There are a few other programs that you can try. I encourage you to try them out. But for the time being, I'm loving this little thing. You can hang this up. You can do whatever you want with this. But make sure to have fun with it. There are plenty of other programs. You can program this yourself. Like I said, there are going to be these 2 little holes at the top marked 0 and 1. Those are just 2 more pins that you can use. And in the Arduino IDE, you just designate, pin 0, pin 1, whatever you want to do. So last year, unfortunately, the workshop didn't work out. But one of the things we tried doing was having it play music. With these extra pins, you can go ahead and program them to play music. Probably not going to be able to put a file on there, but it would be kind of cool if you could, I don't know, just get it to play, we wish you a Merry Christmas, something along the lines of that. And all you need is a little tiny speaker. Sometimes you might have them laying around in a parts kit or something like that, or there are plenty of videos on how to build your own if you're getting creative with that kind of stuff. But there you go. This should be a working project. If you have any issues, I will be holding a sort of office hours in the next couple of days. And I'll make sure to send that out in an email, or I'll be putting it in the description as well. So if you have any issues with that, hop on the office hours. We'll try to get things worked out for you. And I hope you really enjoyed this project. I know it takes a little bit of soldering skills, a little bit of programming skills, but hopefully I've supplied everything that you need to get to at least this point. I believe there are 4 example programs. Go ahead and play around with them a little bit. Oh, accidentally put a Z in that program. But yeah, thank you guys so much for watching. I'll go ahead and do a quick little montage of how to put the battery in and how to get that working, and then we'll wrap up this workshop. So let me go back to the battery. I'll explain that and we'll close. Okay, so we're back here, small scale baby camera. You'll notice that there are these 3 leads coming out the bottom. These are the 3 leads that we used to program before. I just unplugged it from my Arduino, but for now, this is all we're gonna need. Go ahead and grab your battery. I have mine on hand, and we're gonna take a look at some of the pins on the battery. You'll notice that at the top, you're gonna see a 5 volt, D minus, D plus. All of those are gonna be when this is plugged in. You're gonna get the clean 5-volt output. We don't need 5 volts. This is actually gonna go down all the way to 3.3 volts, and sometimes lower if you wanna bump the speed down on the ATtiny even more, say to 4 or 5 megahertz. But the ones we're gonna look at are actually the far right ones, if you're looking at it like this. The far right ones, you're gonna have one that is ground, and it's actually, the labeling is underneath the pin, and the other one is battery voltage. So using your leads here, I'm gonna go ahead and plug mine into the front. I'm gonna go ahead and, they won't stick in, you can go ahead and solder them if you really need to, but my VDD wire is gonna go into the bat, and my GND wire is gonna go into the ground. You'll see it'll start to come to life. Look at that. So this is how you can go ahead and power these remotely. You can connect up to 2 of them, I've noticed, and they work perfectly fine. Now you don't want to connect them in series, you want to connect them in parallel so that both of the ground wires are connected to the same ground there, and both of the VDD wires are connected to the same V battery there. But there you go. So I wish everybody a happy holidays, and I hope everyone will have a great break. I'm gonna go ahead and bring this to a close. Like I said, if you have any questions, please do not hesitate to leave them in the comments down below. I'll try to get to them as quickly as possible. I will leave a, not a link, but I'll definitely leave a date to where I'm gonna be holding about 2 hours worth of office hours. If you wanna hop on, we're gonna go ahead and be troubleshooting any problems that you have with this. If you have questions about programming, you have questions about the design, anything, I'll be there to answer them for you. So go ahead and hop on those in the next day or so. Thank you everybody so much for attending this workshop. Thank you for participating. This is one of the most complex workshops that we've done this year, getting everything mailed out, and I appreciate the patience and the excitement that has come behind this workshop, and I hope to be able to do this again either later in the semester or next fall, after next fall semester. So thank you, and have a wonderful rest of your break, and I wish you all very happy holidays. See ya.